This is a projectile motion scenario. In this equation, we are representing a flotation device above the water after x seconds. And it follows this equation here, where v sub 0 is your initial velocity and h sub 0 is your initial height. So right now we know the initial height is 15, which is right here on the graph, and we are trying to find the initial velocity. So I'm going to rewrite the equation here. The height in relation to time is equal to negative 16t squared plus our initial velocity times t plus 15. So in order to find the initial velocity, I'm going to use an ordered pair from the picture. So 1.33, 0. So I'm going to use that and plug that into this equation here. But you have to know where you're supposed to plug in the 1.33 and the 0. So again, this represents time, right? That's your x-axis. And this represents the height. So that's your y-axis. So this is really your x and this is your y. Or in this scenario, this is your time and this is the height in relation to time. So essentially you're plugging in 1.33 for t and 0 for h of t. So 0 equals negative 16, 1.33 squared plus v sub 0 times 1.33 plus 15. All right. So for this very first term, I need to apply exponents first. I have to take 1.33 and square that. And then I have to multiply that by negative 16. And I get negative 28.3024. And then this is plus 1.33 v sub 0, and then plus 15. So right now, I'm just going to combine these, okay? So if I take negative 28.3024 and add 15 to that, I get negative 13.3024 plus 1.33 v sub 0. All right, so now I'm going to add 13.3024 to both sides. So I get 13.3024 is equal to 1.33, our initial velocity. And then the very last step would be to divide both sides by 1.33. So our initial velocity is equal to 10. So my final equation, I can write the actual equation now. Height in relation to time is negative 16t squared plus 10t plus 15.